Throughout this video, we're going to be going back and forth between the lab and this topology. But just to give you a rundown of the topology, our Fortigate 1 is our main site. It connects us to the internet via two separate ISPs, ISP-A and ISP-B. And of course, downstream to Fortigate 1, we have two small branches connected by Fortigate 2 and Fortigate 3. According to this table that is on the diagram, we're going to route from Fortigate 1 to Fortigate 2, Fortigate 1 to Fortigate 3. We're going to have static routes defined so that we have end-to-end reachability between Fortigate 1 and the remote sites. And then we're going to configure BGP, and Fortigate 1 is going to advertise 1.1.1.2. Fortigate 2 will then advertise 2.2.2.2 as well as 2.2.2.4 into BGP, whereas Fortigate 3 will advertise 3.3.3.2 into BGP. Fortigate 1 will then also advertise 1.1.1.3 into OSPF. Fortigate 2 will advertise 2.2.2.3 as well as 2.2.2.4. And this is on purpose because I'd like us to observe and see what happens to this prefix when it's advertised by both BGP and OSPF. We'll take a closer look and see, with this prefix 2.2.2.4, how is it going to be entered into the routing table? Which protocol is going to be preferred? So then let's jump onto Fortigate 1 and start configuring our interfaces. We're going to start first with port 1 and 2 connecting to the internet. And for that, we go to Network, Interfaces. Port 1 connects us to ISP-A, so I'm just going to call this ISP-A. Make that a WAN type interface. And the IP address is 172.16.10, and we are .2 in a /27 network. I'll allow ping on this network, and I'm going to copy this because I'm going to need to use it a little bit later. Port 2 connects us to ISP-B, and I'll call this ISP-B. And it's also a WAN type interface, and the IP address there is going to be 172.168.20.2. That is port 2. I'll enable ping on this interface, and that looks good. Port 3 connects us to Fortigate 2, so I'm just going to label this to Fortigate 02. And the IP address for the segment is 10.160.1, and Fortigate 1 is .1/30. And for this interface, and actually both port 3 and 4, I'm going to configure, or I'm going to allow SSH and ping. Let's do the same thing on port 4. I'll name this to Fortigate 3. Our interfaces are configured. Now it's time for verifications. This looks good. So I suppose the next thing is to create our static routes. And for that, we navigate down to Network, Static Routes. And right now we don't have any. And if we go back to our dashboard and look at the network monitor, we can see now that the number of connected networks has increased. We now know of 5 networks, which are all of them of the type connected because they are directly connected. They're directly configured on our firewall. So let's create our first and second static routes. The first static route is to ISP-A. Gateway would be 172.168.16.10.1, and it immediately picks up ISP-A port 1 interface. And the second is to 172.168.20.1, which is associated automatically to ISP-B port 2. I didn't change any parameters. I didn't change any other values. I just went with the defaults. Now, if we have a look at our dashboard, our network monitor, we can see now that we have connected routes as well as static routes. And connected routes, there's 5 of them. Static routes, there's 2 of them. If we have a look at our static routes, it's these 2 networks that we just configured. We now need to test reachability to see, are these interfaces actually up? Is there a service on these 2 interfaces? Because we might need it later. So to do that, we need to do a ping and source it from each one of the interfaces respectively. Exec ping options source from 172.168.10.2, and then we're going to ping exec ping 8.8.8.8, and we have reachability via the 172.168.10 interface. Now I'm going to change that source to 20.2 and then ping 8.8.8 again, and through this interface we have reachability as well. So it looks like our static routes work, but let's have a look and see what our routing table looks like from CLI. Get router info, routing table, all. We can see that we have these two routes with a legend of S. That means that these are two static routes. Okay, so now it's time to configure Fortigate 2. We're on Fortigate 2, and so far we only have one connected route. We go to network interfaces, we're going to configure port 1, and since this is facing Fortigate 1, I'm just going to call it to Fortigate 01. Fortigate 2 is .2 on the segment, and of course I'm going to do the same thing, allow ping and SSH. That looks okay. Let's have a look at the routing table from CLI. Get router info, routing table, all. We only have two prefixes which are directly connected networks, and we actually now can create a static route. To do that, we go on static routes, we create new, and gateway address is 10.160.1.1, which is our next hop, Fortigate 1, and we can see that there's our static route there. Okay, so one of the things that I want to do is, like we said from our table, we said that we're going to route these IP addresses in the static column on this table. So we want to be able to reach from Fortigate 1, we want to be able to reach 2.2.2.1, which is an interface on Fortigate 2. We also want to be able to reach 3.3.3.1, also an interface on Fortigate 3. In addition to the configs that we have in place and the existing static routes on Fortigate 1, we might as well create two additional static routes pointing to these networks before we go and configure Fortigate 2 and 3 themselves. So the first static route would be to the loopback of Fortigate 2, which is 2.2.2.1. The next one is to Fortigate 3, and the network there that we want to reach is 3.3.3.1/32. Our next hop is going to be 10.160.0.2, which is IP address of port 1 on Fortigate 3. And yes, it picks up the correct interface. Now we have all the static routes that we need as far as Fortigate 1 is concerned. We're on Fortigate 2. Let's configure port 1 interface of Fortigate 2. And this I'm just going to name to Fortigate 1. And the IP address is 10.160.1. We are .2 of a /30 network. Enable SSH and ping. What I haven't done yet is to create the actual loopback interfaces themselves. I'll come back to this a little bit later. So for now, we have our underlay interfaces. Let's go to Fortigate 3. We go to interfaces and configure port 1. I'm going to also label this to Fortigate 01. Allow SSH as well as ping. I'm going to create a static route pointing to the loopback of 1.1.1.1/32 via the next hop of 10.160.0.1 being the port 4 interface on Fortigate 1. It picks up the correct interface. I believe I need to do the same thing. Static route on Fortigate 2, point to 1.1.1.1/32. Our network is 10.160.1, and the next hop is port 3 interface address of .1, and it picks up the correct interface. Okay, so what I meant earlier that the reason I haven't created the loopback interfaces yet, it's a manual process and it's a lot of work. Not just to create the loopback interfaces, but what I've decided to do is I want to be very granular in this lab. I want to create all the interfaces on Fortigate 1, meaning 1.1.1.1.1.2.1.3. I want to create all these interfaces as address objects and then group them and call them Fortigate 1 addresses. And then do the same thing for Fortigate 2 addresses, loopback addresses, 2.2.2.1.2.3, as well as 2.4. And then group those and call them Fortigate 2 addresses, and then do the same thing for Fortigate 3, so that when we start creating security policy, we don't use the any, we actually reference the address objects that exist. And so here's our list, and as you can see, it has loopback 1 address and the address groups at the bottom. So what I'm going to do is just be able to copy paste the whole thing into the Fortigate to create these objects. And we'll start with Fortigate 1 and then move on to Fortigate 2 and then Fortigate 3. Let's have a look at our policy and objects and see if our addresses are there. And our addresses are there, as well as the address groups. This is on Fortigate 1. Fortigate 2, we go and check on addresses, and our addresses are there, as well as the address groups. And I believe the same for Fortigate 3. I feel like there's something that I've forgotten to do, but let's test. Before we can test, we need to create the security policy to allow the ping. So what I want to do is allow ping and SSH. So we need to create explicit policy for this. Let's start with Fortigate 1 first and go to firewall policy. I'll just call it allow ping and SSH. Oh, another thing that I almost forgot. So what's going to happen is we need to be able to specify the destination interface, the source and destination interfaces. And right now we can only specify one incoming interface or outgoing interface. And if where the destination is loopback 1, loopback 2, loopback 3, multiple loopback interfaces, we won't be able to do that. So the other thing that we need to do is to allow multiple interfaces in security policy. So I'm quickly going to enable that feature in feature visibility and go to multiple interface policies, go to Fortigate 2, feature visibility, multiple interface policies, and do the same thing on Fortigate 3 as well. So now let's go back to Fortigate 1 and create our security policy. Allow ping and SSH, and incoming interface, we want to allow incoming traffic from both port 3 and port 4. And outgoing interface would be, oh, I don't have the loopback interfaces. It looks like we haven't created the loopback interfaces on Fortigate 1 yet. Okay, my script didn't include creating the actual interfaces. It looks like I only created the address objects, but not the interfaces themselves, which is not a problem. We can now create the loopback interfaces for Fortigate 1. Okay, now I'm back on Fortigate 1. Loopback 1, 2, 3 interfaces now created. So as I realized, they were not part of my script. Fortigate 2 also has loopback 1 to 4, and Fortigate 3 as well has loopback 1 to 3. So now let's go back to our security policy and update the policy we have. The intention of this policy is to allow ping and SSH inbound from Fortigate 2 and Fortigate 3. So the inbound interface, incoming interfaces would be port 3 and 4, and outgoing interface would be loopback 1, 2, and 3. Now that looks better. And the source is all addresses on Fortigate 2 as well as all addresses on Fortigate 3. And the destination, of course, is any address in the Fortigate 01 address group for ICMP and SSH. This looks okay to me, and we can now save. So now we're going to do the same thing on Fortigate 2, create a similar type of policy new, allow ping and SSH. The incoming interface, of course, is going to be port 1, and outgoing interface to the loopback interfaces would be the loopbacks themselves, including loopback 4, and the source would be all addresses on Fortigate 1, and the destination is all addresses on Fortigate 2, and the service would be all ICMP as well as SSH. If we discover at a later stage that we want to do something else and permit some other service or some other application, we can do that. But for now, this looks okay to me. We do the same thing on Fortigate 3. Firewall policy, create new. Allow ping and SSH. And the incoming interface, of course, would be port 1. Outgoing interface, it's our loopback interfaces. And our source, it's Fortigate 1 addresses. Destination, Fortigate 3 addresses. We allow ICMP as well as SSH. Okay, so now our firewall policy is in place. That means we are ready for testing. Okay, so I'm going to do this test from Fortigate 1, and I'm going to source the traffic from 1.1.1.1, and I'm going to ping 2.2.2.1, and the traffic is permitted. And I'm going to ping to 3.3.3.1, and the traffic is permitted. And I guess just for the sake of completeness, let's see if traffic initiated from Fortigate 2 and Fortigate 3 would actually make it to the loopback interface of Fortigate 1. Exec ping 1.1.1.1, and this traffic is not permitted. Let's see why not. Do we have a static route first of all? Yes, we do have this. We do have a static route. Wait a minute. I'm actually going to do this test again just to pay a little bit more attention. But while I'm doing that, I'm going to do diagnose sniffer packet any exec ping 1.1.1.1. The traffic is making it to Fortigate 1. I'm going to go back to Fortigate 1 and look at the interface itself and see why are we not seeing a response. So the problem is, as it turns out, Fortigate 1 doesn't have a route to 2.2.2.2. So I'm going to do this ping test from 2.2.2.1 and check. And that is permitted. I'm going to create a static route to 2.2.2.2. I prefer that to be 2.2.2.2 and this to be 3.3.3. It's just easier to work with. Okay, so let's do this test one more time. Ping options, source 2.2.2.2, 1.1.1. And we have reachability there. I'm going to do the same test from Fortigate 3. 3.3.3. And ping 1.1.1.1, and the traffic is permitted as well. So far we've been able to prove that our static routes are in place. We have security policy allowing this traffic, and the next thing that I want us to do is BGP peering between Fortigate 1 and Fortigate 2, as well as Fortigate 1 and Fortigate 3. And then have a look at what the routing table is going to look like after that. Since we are on Fortigate 1, we'll start our configs on Fortigate 1. Just as a reminder, we said that Fortigate 1 and Fortigate 2, they're going to have an eBGP neighborship, meaning it's an external BGP peering, where Fortigate 1 will be in the autonomous system number 100 with the router ID of 1.1.1.1, and the neighbor is going to be Fortigate 2 with an IP address of 10.160.2. The remote AS would be 200 for Fortigate 2. And so the networks that we want to advertise into BGP, we said that Fortigate 1, according to our table, Fortigate 1 is going to advertise 1.1.1.2/32. We also have to advertise the directly attached networks on port 3 and 4, since this is where we're going to be running BGP, and that is 10.160.1 and 10.160.0 and 10.160.1. .160.0 as well as 10.160.1.0 and 111.2. That's what we're advertising into BGP. This looks okay to me. I believe we can now go to Fortigate 2 and configure BGP. And for that, we go to network, BGP. Once again, Fortigate 2 is in autonomous system number 200, and we have the router ID of 2.2.2.2. From Fortigate 2's perspective, the neighbor is Fortigate 1 with the IP address of 10.160.1.1 and the remote AS of 100. And the networks that we're advertising, let's actually start with our directly connected link, 10.160.1.0/30. We said that we're advertising our loopback 2 interface 2.2.2.2 as well as 2.2.2.4. This is Fortigate 2, by the way. So this will be 2.2.2.2/32 and 2.2.2.4/32. And this same prefix 2.2.2.4 we're going to also advertise into OSPF. And I believe this is okay. This looks okay to me. Let's go over to Fortigate 3 and do the same thing. Network, BGP. Fortigate 3 is going to have an iBGP peering with Fortigate 1. So the autonomous system number there is going to be 100. And the router ID for Fortigate 3 would be 3.3.3.3. And we're peering only with Fortigate 1. So the IP is 10.160.0.1 with the remote AS similar to ours, 100. And once again, we are advertising the network that's directly attached, that's 00/32, as well as the loopback interface that we said that we're going to advertise according to the table, which is 3.3.3.2. All right, so I'm going to check the BGP peering between Fortigate 1 and downstream neighbors from Fortigate 1. It'll show me both of them at the same time, or at least I expect it would. Get router info BGP, let's just say BGP summary. Okay, we have BGP peering with 10.160.1.2. That's Fortigate 2. We don't have our BGP peering with 10.160.0.2. Let's see where we went wrong. Oh, we haven't defined 10.160.0.2. We need to add that. So what we have is 1.2. We need 10.160.0.2. And 0.2 is AS 100, similar to Fortigate 01. Okay, let's try this again. Get router info BGP summary. And now we have both neighbors, and the BGP peering for both has come up. We can see that we are learning prefixes. So from 10.160.0.2, which is Fortigate 3, we're learning only one prefix. And from Fortigate 2, which is 10.161.2, we're learning two prefixes. So you'd remember that from Fortigate 2, we said we advertised 2.2.2.2 as well as 2.2.2.4. So this looks good. If we go to the dashboard on Fortigate 2, we can see now that the routing dashboard looks like it has static routes, BGP, as well as directly connected routes. If we go to Fortigate 3, I expect to pretty much see the same thing. The more interesting routing table, of course, would be Fortigate 1. When we look on Fortigate 1, we can see a lot more prefixes, and we can see that this is BGP, static routes, and of course directly connected. And before we look further into the routing table and the route monitor, I think we need to add the last protocol, which is OSPF. Let's quickly configure OSPF so that we have our complete routing table, so that when we focus on the routing table, we have all our ducks in a row. Once again, I'm going to start on Fortigate 1. Go to OSPF. I'm going to use the same router ID. So Fortigate 1 is going to be 1.1.1.1. I'm just going to use area 0. I'm not going to change anything there. And the networks that Fortigate 1 is advertising, 1.1.1.3/32, and that's about it. And the interface we want to participate in OSPF would be port 3 and 4. I'll just call this port 3 and then select port 3 interface. I'm not going to change any other values. I'll add port 4, which leads us to Fortigate 3. And I'm not going to change any other parameters here. So just to recap, we have our router ID, we have our area 0, we have our physical interfaces, as well as the networks that we want to advertise. I believe this configuration is complete. And now we'll quickly hop on to Fortigate 2, jump to networks, go to OSPF, and do pretty much the same thing. Router ID for Fortigate 2 would be 2.2.2.2. Once again, area 0. The networks that are going to be advertised by this device would be 2.2.2.3 as well as 2.2.2.4/32. We're going to advertise as well 2.2.2.4/32. And this is Fortigate 2. The active interface in OSPF is port 1. Port 1. Select that. And I believe we're done. I'll go into Fortigate 3. Go to network. OSPF. Router ID for Fortigate 3 would be 3.3.3.3. Our areas, area 0. So Fortigate 3 is advertising 3.3.3.3/32 into OSPF. And of course, the only interface that's active would be port 1. That's our OSPF interface. And notice I'm going with defaults. I'm not doing any other configurations. That is for another lab some other time. Okay, so now I expect that our firewalls have fully converged. Let's go back again to Fortigate 1 and look at the routing table from the OSPF side of things. Get router info, routing table, OSPF. No route available. Get router info, OSPF neighbor, and it says I have no neighbors. Okay, once again, this another thing we need to do Your OSPF will not converge if you don't advertise the directly attached network, which is exactly what I've done. I didn't advertise the 10.160 network, and I need to do that. From Fortigate 01, I'm going to advertise 10.160.0.0/32. as well as 10.160.1.0/32. No, /30. So now I've advertised the two interfaces, port 3 and 4, 10.160.0/30 and 10.160.1/30. (10.160.0.0/30). Okay, so now I expect that we'll see something different when we look at the OSPF neighborships and the routing table. Get router info OSPF neighbor. Neighbor 3 is up. Let's see why neighbor 2 is not up yet. Get router info OSPF neighbor. Maybe it just took time. Let's have a look again. Get router info OSPF neighbor. Yeah, so now we have both Fortigate 2 and Fortigate 3 in the full OSPF state. Let's look at the route monitor. Now we can see that we have, in addition to our directly connected networks, from Fortigate 1 perspective, this is the networks, how many prefixes we're learning from each routing protocol. So if we go onto OSPF, we'll see that it looks like we are only learning from OSPF 2.2.2.3, which is a prefix coming from Fortigate 2. I don't know why we're not learning 3.3.3.3. Let's have a look. Let's do a route lookup and then see where 3.3.3.3 takes us. Oh, 3.3.3.3 is learned via static. I remember I changed that out of convenience, but we should actually be advertising 3.3.3 via OSPF. So then instead of 3.3.3.3 via OSPF, what I'll do is create or advertise 3.3.3.1 via OSPF from Fortigate 3. Let's have a look at that. Yeah, so this would never work because a static has a higher administrative distance, but this is exactly what we're going to be talking about now. So I'll change this to 3.3.3.1 so that we have one static prefix being advertised and, or not really advertised, one statically routed prefix and one dynamically routed prefix per protocol. So now when we look back at OSPF, maybe I just need to refresh this. Our routing table has converged and the 3.3.3.1 prefix has come across as an OSPF network, and we can see it on the route monitor. Now let's actually pay a little bit more attention on the routing table via the route monitor. We know that we're not even going to pay attention to our directly connected prefixes. I think the thing to have a look at first is the routing decisions and how to interpret the routing table. As we can see that all the directly connected networks have an administrative distance of 0. And I went with the defaults. I didn't change anything with my configs. This is directly connected. And then when it comes to the static routes, we saw that we didn't change any metrics. We didn't change any other config. And so by default, all the static routes have an administrative distance of 10. So this means that in terms of preference, the Fortigate would choose the routes that cost less, meaning that have the lower value with regards to the administrative distance. And in this case, it's directly connected. If the Fortigate has a path via directly connected interface, it'll choose that path. If it doesn't, and there's a static route, it'll choose that prefix via that path, via that static route. So the static route would come after the directly connected interfaces, and after that we would learn from BGP. And BGP has an administrative distance of 20, and you'll notice that this BGP metric, this network comes from Fortigate 2. Remember, we said that Fortigate 2 has an eBGP neighborship with Fortigate 1. That means eBGP has an administrative distance of 20. After the static routes, the Fortigate would prefer any route learned via BGP, specifically eBGP. And the next preference, of course, would be OSPF, because OSPF has a significantly higher administrative distance of 110. So between the two prefixes, if the same network is being advertised by OSPF and BGP, like we did in our table, where we advertised 2.2.2.4 in both BGP and OSPF, we saw that the prefix came across as a BGP prefix, and there it is, 2.2.2.4. It's registered in the routing table as a BGP prefix instead of an OSPF prefix, because when OSPF presents it, it presents it with an administrative distance of 110, and of course the lower is better. 2.2.2.3 is an OSPF prefix coming from Fortigate 3, and last but not least is the iBGP, which is the interior BGP that has an administrative distance of 200. So all the theory about route lookup, route calculation, path selection pretty much boils down to administrative distance, and the defaults are good enough. You are not meant to change the defaults, even with static routes. So with our static routes, an interesting thing we have here is that we have two static routes with the same administrative distance to the same network. Now, how does the Fortigate choose which prefix is going to take precedence? Or you as a network engineer, how do you decide? Let's say in this case, you want for ISP-A to be your primary link. How can you ensure that all your traffic is going to be going via ISP-A? The best thing to do is not to change the administrative distance. I don't like to change the administrative distance and fiddle with those values. Instead, if I know that ISP-A is going to be my preferred path, the thing to do, the recommended best practice, is to change the priority. So, of course, lower is better, and I'm going to change this to 10. This is ISP-A, and then make ISP-B to be priority 20. So now if we look at this from the routing table, get router info routing table static. We can already see that we have 10 for administrative distance, and for priority, the first prefix via 172.168.10.1 next hop has a lower priority. And when we do, let's say we want to go to 8.8.8.8 and we want to know which way we're going to go. Let's use the GUI for this. We go to the route monitor, and then we use the route lookup utility. So let's say we want to go to 8.8.8.8. As you can see, the Fortigate will highlight the path that the traffic is going to exit out of, and in this case it's going to exit out of port 1. And we can very easily change this around and lower the priority and make it 5 for ISPB. And when we do the route lookup again, we want to check what is the path, which interface is going to be our egress interface, which path the Fortigate is going to prefer. 8.8.8.8. And this time you can see it's going out 172.168.20.1. So this is effective, and because of this value, because of the priority, there's no need to modify the administrative distance, and I hope this is very clear. The other thing that I wanted to put across is that the RIB table, the router information base, it's considered to be the standard routing table. And I've been doing this throughout the lab, but the way you display the RIB table is through get router info routing table all. This is a standard routing table, and this is made up of all the best paths to each of these networks that are listed on the routing table here. So the firewall will select the best path and install it in the routing table, and that is considered to be the router information base. Now you might be asking, what then is the difference between the router information base, the RIB, and the FIB? The FIB is everything that comes out of the RIB and filtered through some system specific parameters to make up an index of routes that is used by the firewall to forward traffic. It looks very different from the standard routing table, even though it contains information that was extracted out of the routing table, out of the RIB. And the way you display the FIB on the Fortigate is get router info kernel. And I think the screen is a little bit, I'm going to SSH to the firewall so we can see this properly. So that is get router info kernel. Like I said, it's the same information, but it is enriched. It has far more columns and far more detail. The Fortigate actually uses the FIB for forwarding decisions. So when they refer to the route lookup, it's in fact the FIB lookup. And so there was the RIB and the FIB. The other table that I want to show you is the session table and how the session table gets populated. Once again, we'll log on to the firewall. The way to display the active sessions on the Fortigate is diagnose system session list. And here you can see all the sessions that are currently active. And if you know what you're looking for, you'll be able to use filters and find what you're looking for. So as an example, I'm going to start an SSH session from from Fortigate 2 to Fortigate 1. And then so that we can search using, say, port 22 as a destination port to identify that active session on Fortigate 1. So I'm going to SSH from Fortigate 2 to Fortigate 1 to create the session. Exec SSH admin at 10.160.1.1. Okay, now we're SSH'd. We are connected onto Fortigate 1. Now let's see, there must be a session on the Fortigate 1, and let's now try to find that session. And the way to do that, we are back onto Fortigate 1. We go diagnose system session filter. We want to filter with any one of these parameters, but the easiest for us to filter with would be the destination port. So I'll just say filter with destination port of 22, which is the default SSH port. And then diagnose sys session list. And we can see protocol 6, which is our TCP protocol, and we can see that we have this line over here that says this traffic is originated from 10.160.1.2, which we know to be an IP address of Fortigate 2, coming off this ephemeral port going to 10.160.1.1, which is, as we know, port 3 interface of Fortigate 1 on port 22. And then we see traffic in reverse from 10.160.1.2 from port 22 back to that ephemeral port. And furthermore, we know that this traffic was allowed by a policy, and the policy that was responsible for allowing this traffic is this policy ID over here, which doesn't make too much sense to me. Typically, you'd see single digit numbers, but this doesn't make sense to me. But yes, this is the policy ID that is allowing the traffic. Show firewall policy. I'm curious to see what I'm going to find when I copy paste this value. Yeah, that policy doesn't exist. There's only one policy, and I would have expected for this to say policy number 1, because there's only one policy on the firewall at the moment. So there was the fib table, the rib table, as well as the session table. And the last thing that I want to demonstrate in this video is the reverse path forwarding. With reverse path forwarding, let's say, for instance, you're connecting from Fortigate 2's loopback interface with IP address 3.3.3.3, and you're connecting to Fortigate 1. In fact, this did happen to us earlier. I didn't have a static route pointing back to Fortigate 1. We didn't have static route 3.3.3.1 pointing to Fortigate 2. And when I tried to connect to Fortigate 1, that traffic just died. It didn't get anywhere. In fact, I want to do this again, but the theory is if you're coming from Fortigate 2, connecting to Fortigate 1 from an address that Fortigate 1 doesn't have a path to, doesn't know, it's not advertised by any dynamic routing protocol, and there's no static route for it. If it doesn't have a path back to the source, if we're coming from 3.3.3.1, but Fortigate 1 doesn't know how to get to 3.3.3.1, that traffic will be dropped by RPF, reverse path forwarding. So let me demonstrate that. I want to remove that prefix from dynamic routing protocol so that Fortigate 1 doesn't know of that prefix anymore. So from Fortigate 2, we want to use, let's say, 2.2.2.3. I'll delete that. And then now let's check if Fortigate 1 knows of 2.2.2.3. Get router info, routing table, all, grep 2222, exec ping 2.2.2.1. Okay, so it looks like we don't know of 2.2.2.1. So I'm going to run a diagnose debug flow on Fortigate 1. Diagnose debug flow filter. Let's filter by an address 2.2.2.1. Diagnose debug flow trace start, I'll say 20. diagnose debug, enable. And then I'm going to source traffic from 2.2.2.1. I'm just the ping 2.2.2.1 exec ping 1.1.1.1, which is an IP address on the Fortigate, on Fortigate 1. And immediately we can see that we know we don't have a path to 2.2.2.1, and as you can see, reverse path check fail, and the traffic is dropped. There's not much I want to say about this anymore, and so far we have covered quite a lot of things, and so let's recap. We looked at the route lookup process. We looked at the equal cost multipath. We also look at the router information base and the difference between that and the forwarding information base. We know that the fib is made up of entries that come out of the RIB. And we looked at the session table and how the session table is populated. And what you need to know about the session table is that the Fortigate looks at the first packet that the sender sends that goes over the Fortigate, and also it looks at the traffic coming from the receiver, but only once. So it essentially does 2 lookups, and that's it. And that's how it builds the session table. After those 2 entries are known from the sender and the recipient return traffic, the route lookup doesn't happen again. So the session table is built, and all the subsequent flows would be associated with that session. And then we had a look at the reverse path forwarding and how it works. We looked at the path selection from the Fortigate and in view of the different routing protocols, BGP, iBGP, eBGP, OSPF, and static routes. And this concludes it for this video. It's been quite a mouthful, but I'd like to thank you for watching until the end, and thank you for supporting the channel. I'll catch you in the next video.